Guys, this is Manak and you are watching Civil Bros. So today we are again coming with another model of Tekla Structural Designer. So here guys, we have a building here. This is a simple two-bedroom building with a staircase as you can see here. And I have made the center line plan of this particular building in AutoCAD in a separate file. The unit is mm, and as you can see all the center line I have put in a separate layer here named CL, because in Tekla Structural Designer, if you need to import it, you need to put this in a separate layer. So once you have put this in a separate layer, then you can use the command dxf out and save it as a dxf file, and click on save. Then it will be saved as a dxf file, the particular file which you're going to import in the Tekla Structural Designer. So having done that, go to Tekla Structural Designer, open the software, and then start with the making of the construction level. So if you are unable to download this software, there is a link in the description. The original software will be downloaded for 45 days trial version. You can use that for learning. Okay, so now after this has been done, you can go to model and you can go to construction levels. We'll set some more levels here. Let's insert level below. Let's give this, let's say approximately foundation level is 1.5 meters below. This is the plinth level, and insert a level above this and give it a spacing of, let's say, 3 meters. Okay, and this will be SSL, means structural slab level. It has a slab. Others can be TOF and SSL. TOS or steel can be used when you are designing steel structures. Okay, give this a slab thickness of let's say 100 mm, or you can give as 125 mm here to start with, and after that just insert another floor above. So it is basically now G plus 1, ground floor plus 1 floor, this two-story building with 2 bedroom. Okay, now just click on OK, and let's see whether our file which you made is correct or not. To import, let's go to this import dxf option and we'll import the file which we have created. So here now we only need the center line as actual grid. The unit is, the file is click on next. Can click on bilayer and then select all the levels and then click on finish. So click on escape. So the grids are imported fine. Next, just import the shadow. Again, click on the center line, and here just except the center line, we'll import everything else. Units as a shadow. We need to zoom in. So now, as you can see, we are done here. And first of all, the thing is we'll need to place the columns. Select the columns here, and we will make some properties here. As you can see, there is no property selected. So first of all, let's go here, and there's M20 concrete. Column size which we are giving is here, which we want to give is 300 and 300, and let's see it will pass or not. If it doesn't pass, then we can increase it anyway. So 300, 300, and this FE 500 is the grade of steel which we are providing. And let's provide the columns here. Now we provide here, it comes at the one of the end. So just press Ctrl plus Z, and then first of all let us save this thing. Before saving it, just click on this automatic, untick on this automatic alignment. Now it will be aligned to the center, and then just save this. So we'll save this as C 300 cross 300 and click on OK. And after that, we'll place the columns here like this. At all the grid intersections, it will place. If there is a point where there is a grid intersection but no column, you can just unselect that. Okay, so the columns have been selected, and you can see the 3D view. These are the columns starting from the foundation level to the top floor level. These are the columns here, and you can make another level just for these 4 columns because this will go up to separate level. So you can do that, or you can do that later also. Okay, so first of all, let's add the beams here. So we'll take the beam here. Since it's a plain beam, let's go with 250 to 300 for the plain beam. And you will see if it is passing or not, 250 to 300. And click on OK. And here, these parameters, let me do this as FE 500 for the grade of steel. And after that, click on Save. We do this P 250 cross 300. Click on OK. All are the primary beams, so you just can drag it like this and see in the structure 3D. These are the beams which have been provided. Now, a little bit adjustment might be required here in terms of the beam here, so we can see which direction our beams and columns are flush, and then we can actually do it. So we'll just see our CAD file here, and this particular beam is flush in the outside, and all the outer ones are flush in the outside actually. So here we have to do the calculation here. So this is a 250 mm beam, 300 mm column, so remaining is 50 mm. So here they have divided, like if it's the center 25 mm this side, 25 mm this side, so the beam needs to come 25 mm in the left side of the screen. So let's see how we can do that. Here we have an option of, let's see, alignment. Okay, this is center and minor offset. Let's see, give here 25. Let's see what happens. Okay, it goes this side, so you have to give minus 25. Now it is good. So similarly for this one, go click on this and go to alignment. We just give this as 25. This will go here. And now for this one, just click on this alignment. So major offset at the top, so we'll need to deal with this. And this one, since you need to move it this in this way in the bottom, so let's give this minus 25. Let's see if it works. Okay, nothing happened. Enter. Okay, so this seems nothing to happen. Okay, just click on this 0, and then here let us try to change this. Let's see, 25. Okay, this 25 means it will come downward. So you can use this minor offset. Major offset actually does changes along the other plane, along the the y-axis here. So you can use the minor offset to just change these things. And this also, this particular beam also, you see the CAD file. As you can see, this is flush along the this outer of this particular bedroom. So just click on this, just go to alignment, and let's give this 25. So it's done. For this also, click on this 25. Okay, this is a we have a problem here. This is supposed to come in a single line. Just press Ctrl plus Z and make sure we have selected the entire beam here. And then again, let's try. Go to alignment and select 25. Okay, now it's good. I think we hadn't selected there might be a glitch. The software hadn't selected the full beam, so now it's okay. It's outside of this particular, now this top side. This also select this. Again, I'll just escape and make sure the express thing is selected. Escape and then select, and then go to alignment. And then make this as 25. Okay, 25 comes down, so it will be minus 25. Now it's okay. All the outer ones are okay. Now this one is remaining actually. So let's see in the CAD file in which direction the be. Okay, it's along the staircase. So we'll just do this. We need to move this to the right side. So moving to the right side here, and go to alignment, and then just make this, sorry, this one minor offset of, let's say, 25. So this is flush along this. So now, as you can see, SSP is perfect as per our architectural plan and the beam column management. So this particular arrangement is now perfect as per our plan. So we can see it in structure 3D view. So now we need to move on to other options. So we can just go to the next level here, go to structure, go to levels, then go to structure one, and then again here we can just copy all the beams which we had from the particular plinth level. So for that we'll just go to structure 3D, and we'll just go to construction levels, and then after that we'll just go to this, make this as base, click on OK, go to construction levels again, make this as unique, and click on OK. Okay, now we can go to structure one, and click on slabs here. So both these are two-way slabs, so just you know you can just select this two-way slabs here. These two-way slabs you selected here, 125 mm thickness, and then go to structure 3D, and then we can copy this to the next level, construction levels, and then make this source as one, click on OK, and go back to construction levels, make this source as unique, click on OK. So this is done, and now for the topmost level here, just select, press Ctrl and select all these four columns, and then go to your construction levels and insert level above this. This height can be around, this is depends 9 feet or 8 feet. It can be like this. So I'm giving here, let's say 2.74, approximately 9 feet. So let's give 2.74 for the headroom, and then click on OK. And now this four columns are selected. The top level, just make this as this one. So this is done, and let's go to the topmost level, and then let's select the beams here, and we'll select the one beam which you have made, and then make the beams here, and also give a slab here. This will probably be a one-way slab. Let's just check here, measure, this is 2 and this is 4.2, so this is clearly a two-way one-way slab. So for providing one-way slab, just select the slab, and then just make sure if you add a new slab, and after adding new slab, you can just make this as decomposition as one way, and see the direction like this. So like this you can provide a one-way slab also here, and at the end if you want to make this as fixed as you do in TAD Pro, just make this support as fixed. By default, if you do this, there will be no changes in the result. But if you want to make it technically correct everywhere, so we can just make this, select all these supports, and make this two as fixed as well. Okay. So now we have fixed supports, we have our crane beam, we have our roof beams. So we are done here. One thing we'll do, see our roof beams, we need to give higher dimension here. So the roof beams will select here like this and like this. Okay, just need to press Ctrl so that everything is selected here, and you have pressed Ctrl and selected this. Let's select for these. We'll see if it is passing, then we'll decide. Okay, now just go to this and select this beams. So only beams are selected, not the slabs. And now you can see the particular group here. This is the group, this is the beam, and let's see, we don't have the section here, so let's select the second option, that is the beam spans, and then we have the section. So we want to change the section and go to new edit, just click on 350. The depth we have increased a little bit because the roof beam it might not pass with 300. Let's give a higher thickness. So we have provided 350 mm thickness to the particular beam here, and in the headroom part also, if you need, we'll provide. Now let's go with this, and this is done. So the modeling is now complete for this particular building. So Now we'll go to the loading part. So we'll see the loading part. First of all, we'll provide the dead load for the walls. So providing the dead load for the walls, we'll go to the structure base and we'll select the load. Now we'll select this dead load option, full UDL, and then select the dead load seats. All these walls will be a 5-inch, walls here. So 10-inch walls has, and we will be using red clay bricks. So 10-inch walls has approximately 14 kilonewton per meter for 3-meter walls, and for the half-inch wall there will be 7. So we provide 7 for the walls, all the walls, and for the parapet walls we provide, let's say, 3. Okay, if you want to know the calculation, then I have given a link in the description of the YouTube video that that contains the dead load explanation, which are done for the ETABS part. You can check that out. You can understand how to calculate the dead load. So in the plinth level, let's provide this load of 5 kilonewton per meter here along all the beams. Just simply clicking on all the spans will provide the loads here. Let's check in 3D here. Okay, this is good. And here we don't need to provide any floor finish load, because this is the plinth level. All the loads will go directly to the floor and directly to the soil here, since the sand filling is done below the PCC. Okay, here also you can watch the loads here. Just click on this tab, you can watch the loads. So let's move on to the next level, that is structure 1 here, and then we'll just select this dead load. And after selecting dead load, just click on this option of full UDL, and again just make this as 7 kilonewton per meter, and then provide it along all the spans here. So after you have provided this, and simply go to here level load. Our intention is to provide a floor finish load of 1 kilonewton per meter. This covers all tiles, flooring, any types of flooring. Maximum is selected as per the IS 875 part 1, which is the code for your dead load. So sorry, part 2. So this, just select this, and after that you can see the load here as well. So this is the particular load for your walls, and this is the floor finish load. Both types of load have been provided. So let's go to the terrace floor, this one. So on the terrace floor, we'll just go here, and here we will only provide the parapet wall load. So just will go to this particular option of your dead and the full UDL, and here of 3 kilonewton per meter, we'll select this load and then just provide it. So here I'll just press Ctrl plus Z. So here remember that along the staircase portion, you don't need to provide any load here of 3 kilonewton per meter. It will be much higher because it has a headroom portion. So along the boundary we have provided like this, and along this staircase portion we'll go with the default 7, because there will be a there will be a headroom of this. The load has to be taken into consideration. So like this we have provided. And if you check out here, a floor finish load you don't need, because this is a slab. So this is the load switch we have provided. Pretty much this is small, very small structure, but it covers everything. Okay. And now let's go to live load here, live load part. So let's go to structure 1 first, select the live load for the imposed load, and go to level load here, 2 kilonewton per meter as per IS code here. Just select this floor, and then go to structure 3D. So we provided the live load here, it's 25 part 2. So live load has provided in this floor, and in the in the terrace portion also you can provide the live load. It is if because some people go there, so you can provide the live load as well in the terrace portion. And if you want, if you can not provide a particular load as well, but since the terrace is mostly used, let us provide the load to consider the safety purpose. So just select the imposed load here, and here let's go here as your level load, and then just provide this as 2. So we have provided this level load. So let's see if we just want to change this imposed. So provided the imposed load in these 2 floors. Okay, and of the headroom it is not needed, because many people doesn't use any headroom for that kind of purpose. So these are the loadings, dead load and the live load. And now we will take into consideration the wind load. So since the building height, as you could see, if you just go to model and then measure it, the particular height from the plinth level, you can see the building height is 8.74 meter. So it is not exactly in the zone. It is less than 10 meters. So you don't need to provide the wind load here. But we do need to provide the seismic load if it is in the zone 4 or the zone 5. For zones less than zone 3, we don't need to provide. Uh, it is optional. But if we have zone 4 or zone 5, if your uh, you know area lies within the seismic zone 4 or zone 5 as per IS 1893, then we need to provide. Okay, or any in any code, if you're in a high earthquake prone area, then you need to provide it. Okay, let's see how to provide the earthquake load. So go to load here, and here you have an automatic option of seismic wizard. Then select code spectra that's recommended, and then just need to select this seismic zone. I'm selecting seismic zone 5 because the location is Vatala, which is in seismic zone 5, and importance factor also for residential buildings is 1. And then click on next, and we'll use here model response spectrum analysis. There are two methods which you can use here, and click on next, and we'll use here you know RC moment testing frame without any moment masonry infills. Then click on next, and here we'll use here moment frame systems, and we'll use RC building SMRF. Okay, and after that we'll just click on next and then select all these things. These are basically dead load and live load, because the earthquake load considers dead load and live load and applies a factor onto it. Let's click on next and then click on finish. So once this is done, it will prompt you to make a combination or load combination with regard to earthquake load. So just click on operating, and then here what we have is the limit state combination, using the LS and working stress method combination using WS. So you need to select only one of the two methods. So we are preferring limit state method now. So all the limit state method is selected. Click on next and then click on finish. So after this is done, and you need to create some load combinations. So these are the by default load combinations. Now just click on generate and then click on next, and then all the limit state combinations are selected as earlier. Then click on next, and then next, and then click on finish. So now just click on OK. So once this has been done, all the combinations considered, now you can just go to design and simply click on design all static. So it will take some time depending on the model, since it's a very small model, but it covers pretty much every aspect here. So don't need to worry here. And now, as you can see, almost all have been designed here. Let's see what is the warning here, and just right click on this particular member and then check member static. Let's see what is the warning here, which has been given. So everything is passing here, but in the actual force in 3D building analysis, the actual force is more here, and it, it seems that it can be ignored, like it is a bit higher than what actually should be. So it can be ignored. If you want to provide this, you can leave it, there is no problem. But here they're issuing an issue for the axial force. Let's see what the warning for the plane beam. I'll tell you that the warnings is always there is a warning here if you're designing by Indian code, but it can be ignored here for the axial force. So if you increase the moment here or increase the load in this particular portion, then this warning automatically goes away. I'll just show you the thing here, what I'm trying to tell. If this is structure base, suppose I'm adding some load to it, then automatically this kind of warnings will go away. So let's go show you. Go to model and let's create some here steel deck, and let me add something and then add some loads also here as your level load. and then just let's click on design and design all static. Then you can see there is no such a warning here. So this is warnings for the axial load can if there is an additional load, then it can be ignored here. So just click on this Control plus C, and then design all static once again. So now you can see everything is good. Let's see the structure base. Okay, this is already provided here. So just select this and delete this loads on the steel decks, and then go back and design it again, because we have to stay true design all static. So as you can see now, the warnings are for the axial force are back. So you can ignore this warning. So it is not much of a big deal. If you can see another method to just eradicate this warning, so you let me know in the comment section. So now the time is for our foundations. Go to foundation here, and just let me just check the settings here, which the reinforcement I want to use. This 10 to 16 selected. I think it's okay. 10 to 16. I just go with the default size here, and select this pad base column. Select the entire thing, and then design pad bases. Pad bases will be designed. Again, there is a warning of your uh, that is development length here, so don't need to worry about that. If you're designing by British code or American code, this warning won't come, but if you're designing in any other code, this warning does come. So don't need to worry about the development length. It's only glitch. Development length is actually provided in the columns, so there is no problem here. Complete cover is okay, and everything is okay here. So let's see the size here. So it is 750 to 750 mm, and the largest size is at around here 815 to 850. I think this is provided. This one is 800 to 800. This one is 800 to 800, and this one is 1000 to 1000. And let's just provide some uniformity to this. This is 900 to 900. This is 800 to 800, and this is 815 to 850. So let's make this all as 900 to 900 here. Let's select this two, and here let's try to change this size here. So here let's see, let's select one first and try to select the change the size here. So yeah, eccentricity, length in x direction, length in y direction. So let's make this as 900 into 900, and also let's select this and make this, because this uniformity actually helps in the site, especially if you're a small building and using not much skill level. If you are giving many designs, then it really confuses it the workers here. And here we have this 900 900. I want to keep only two sizes. Let's keep this, make this also as 900 into 900. And these two, let's click on escape and select it again. So this size 750 is here, and let's see what is this. This is also 750, so we can keep this. I think three sizes there will be after that. So there will be three sizes. This is 750. The front one, okay, there's the obviously less load here, and so it's 750 and 750, and this is 900 into 900. So this is one. Okay, let's keep three sizes here. Made it a little bit more uniform. Using 900 900, one column has 1000, and two columns are having 750 to 750. So depth is for all of them is okay. And let's go and design pad bases if this works now. Okay, so let's see if the size is changed. No, the size has not been changed. Depth for all of them is 300 mm. As you can see, 300 mm, 300 mm, and 300 mm. And the size, we have three number of sizes. Okay, now let's check the columns, one of the columns here. So we go to this, uh, option of review and click on this option of ratio, design ratio. So let's see. I think all of them are pretty much the same here. 0.237. I think there will be 416 or 412 like this. Okay, it's 416 for all the columns. I think 300, 300, 416. This one should also be 416. Yeah, 4 bars of 16 and middle one, I think this is a column which has larger footing. So let's see, check member static, and yeah, this is also 416. So I think we provided a good size and we pretty much safe here. Let's see this particular beam. I think that how what is the reinforcement here? If it is 212, 212 for the first span, 212, 216 for, I think 212, 216 if we provide, then everything will be safe based on this observation. Let's see this one is also passing 212, 212 first span, 212 to 16. So here, yeah, pen beam we can provide 212 to 16, then it will be safe for all the particular spans. Another one which let's check here. Yeah, okay, let's see what the roof beams. I think this one is showing a little bit higher, so obviously this should show higher because this is in the middle. 212, 212 for the first span and the 212, 212 for the next span. So this passing 350 as well. So here, let me check here, 212, 212 first span, 212 to 16. So similarly, you provide 212 and 216, or if you provide like 216 the top and 216 the bottom, then it will also, be passed. So if you just want to play safe, then you can do it like this, 216 the top and 216 the bottom. So check member static here, and yeah, it is also. So a good here in terms of the beams and the columns, that design is pretty much economic and the structure is safe. We've applied all the loads here, and now we just need to just if you want to have an online submission, you can just pick out all the reports here. Just click on report, and here just okay, what are the reports which you want? Let's see. Uh, I want the design report here. So building design here, and just click on show report. Okay, let's see how the report looks like. Building design, there is a warning is showing, so this is a little bit thing, but the designs, all the designs are shown here, so that is better. This is the design report here using the Tekla, and just let me just save this as PDF. Beam group design category, as you can see, this category is maximum URS. This is the warning is showing, but so it would be better if we have something else like which will show pass but warning like this, because it would be better, because anyone who will read the report, they could get a better idea of what is the what are things, right? Okay, so this is one report which we have got, and let's see another thing: building design, building process, building analysis checks. Let me do building loading also, because anyone who is checking should know like what are the loads which we have applied. So it is the proof that like all the loads were applied here, all the loads and load combinations as per the IS codes were applied here. So just select this, and this is also, this is, I think this is pretty good, like this, even if anyone is checking, like it will give a clear idea of what are the loads which are applied. This is pretty good. Okay, now just any other thing which you want, let's see, let's have the uh, any other thing, building loading, foundation reactions. Foundation reactions also, I think let's just take it into consideration. So it will be, yeah, good, because if it is, you can just select the maximum, moment and the maximum forces. You can check manually also using this results, whether the foundation is okay or not. So I'll just download the PDF of this as well. So this is also very, essential. And what are else things you want for the submission, like member design calculation. So I think, yeah, this is also very important, member design calculations. So this will help, like, design calculations of all the members. Yeah, I think this is better than the, earlier one, because it doesn't show any warning here. It shows that, all the members are passing. So this one is a lot better for the report, because each member detailed calculations are there. So it will be more better. Okay, we'll just save this PDF of this particular thing as well. So it is pretty much all. We have, the reports here, and now the another step is there. Before the submission, you need to, if you want to, submit a design, then you need to give the drawings as well. So drawing part is there. I think which will cover in another video. Uh, if required for this particular building, if you want this blog of how to make these drawings, we give you. But now I think this video length is much more, so I'll just make the drawings after, in another video. I'll show you how to make the drawings if you request, because the drawing part is little bit boring. Like, if I make this drawing and then it will take much time. So if you want only, then I'll give. If you want, then uh, let uh, let me know through a comment. I'll just do that for you. Okay. So, and if you have learned something, and if you have watched till now, make sure you like the video. It helps me to reach more people. So wherever you are, stay good, and keep learning. Bye.